Okay, this is section 3.3, part 2. I'm going to do an example. This will be a minimization problem as opposed to a maximization problem. And I need to point out that this is not the same one that's in the book, but it's similar. So you can still utilize the same thought, and so this gives you an extra example if you would like that. Okay, so let's read through this. You've already got your outline, so you can follow along. A nutritionist advises an individual who is suffering from an iron and vitamin B deficiency to take at least 2,400 milligrams of iron, 2,100 milligrams of vitamin B1, and 1,500 milligrams of vitamin B2 over a period of time. 2 vitamin pills are suitable, brand A and brand B, pretty generic. Each brand A pill contains 40 milligrams of iron, 10 milligrams of B1, and 5 milligrams of B2, and costs 6 cents. Each brand B pill contains 10 milligrams of iron, 15 milligrams each of vitamin B1 and B2, and costs 8 cents. What combination of pills should the individual purchase in order to meet the minimum iron and vitamin requirements at the lowest price? Well, that's a lot of information. Okay, so what do we do first? Well, remember you got to get your variables first. So we're going to start out and we're going to say x equals the number of brand A pills, and y is going to be the number of brand B pills. And then from there you're going to make a chart. Now, a lot of times you don't know how big to make the chart, but here's what I know so far. I know we're going to have brand 1 or brand A, and we're going to have brand B. How do I know that goes on top? Because that's what we're going to be finding. And then for each of those, there's 3 things. There's milligrams for iron, and then there's a thing for B1, vitamin B1, and then vitamin B2, and then there's a cost involved, and my limits are over here. I usually formalize that by putting a border around it. Okay, so let's go brand A. See, I'll highlight this so it'll stick out. So what I've got in yellow is everything I need to know about brand A. A brand A pill contains 40 milligrams of iron, 10 milligrams of B1, 5 milligrams of B2, and it costs 6 cents. Now we'll talk about that later on. We could write that as just 6, as in 6 cents, and then remember at the end our whatever number we come up with, I have to change it into dollars, or I could put 0.06. I think you'll find it's easier if I just leave the 6 there. Okay, next up, let's do this. Okay, then we're going to go each brand B pill contains 10, 15, 15, and 8. Each brand B pill contains 10 milligrams of iron, 15 of each of the B1 and B2. So that means I got 15 here and then 15 again right here. And it cost 8 cents. the table really helps you organize your numbers. Okay? What about your limits? Well, your limits in this case are these numbers here. I don't know what shows up. I'll go ahead and do it in yellow. So my limits in this case for iron is 2400. 2100 for this line, and 1500 for this line. And at this point, I can come up with my inequalities. Okay, so you know you're going to have x greater than or equal to 0, y greater than or equal to 0. That's always going to be the case. Okay, and then if you look at the top line here for iron, that's going to be 40 x plus 10y. Now, this problem's a little different than the other example because we have to have at least 2400 milligrams. So this becomes greater than or equal to 2400. The second line will be 10x plus 15y greater than or equal to 2100. And the third one's going to be 5x plus 15y greater than or equal to 1500. And in this case here, I don't have a profit function, I have a cost function. C will be equal to, I'm just going to put 6x plus 8y. Okay. Now I want a graph, so I'm going to come down here, another page coming in. I created this so it's a little bit bigger, hopefully it's easier for you to see. So, since I ran out of room there, I'm just going to go 40x plus 10y, and I'm going to put equals 2400 because I'm talking about the line. So my x-intercept is going to be 60, and my y-intercept is 240. Tell if it's showing up. There we go. The second equation, I got 10x plus 15y equals 2100. So my x-intercept here is 210. My y-intercept is going to be 140. And then the third equation, 5x plus 15y equals 1500. So my x-intercept is 300. My y-intercept is 100. Okay, now I'm going to come down to the graph, and I'm going to have to graph each of these. So, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 units. I should have made it bigger, I guess. Let's say, well, we'll do 10. We'll see what happens here. So my biggest number is 300. So if I make each square 30, I'll do the same thing each way. Makes it easier. That should take care of it. So the first line hits at x equals 60 and y is 240. So we got 30, 60, 90, 120, 150, 180, 210, 240 is right here. So there's my first one. I label it L1, and you know why that's important now. And my tick marks are on that side. The second line has an x-intercept of 210, 60, 90, 120, 150, 180, 210s right here. And a y-intercept of 140, so you got 30, 60, 90, 120, 140, you got to guess a little bit here. 140 is about right there. That's L2. And the tick marks on this one go out that direction. And then L3 is going to hit at X is 300, so there's 210, 240, 270, 300's right in here. And 100 coming this way, so 30, 60, 90, 100 is right in there. Guessing a little bit. So there's L3. And my tick marks for this one come that direction. And then don't forget it's X greater than 0, so I got all of those. And Y greater than 0, which would be all of those. So now you got to decide, okay, where does it intersect? So let's see. Let's use this, see if that works. So my shaded in region would be all of that. So that's an unbounded region, goes on forever. Okay, I also like to darken in my edges. It just makes it look a little better. I'm going to ask you this here in a second. How many edges do I have and how many vertices? How many edges, how many vertices? Well, you've got an edge here, so there's 1, 2, 3, 4, looks like 5 edges. How many vertices? Got 1 here, 1 here, 1 here, and 1 here. Darken those. And I'm doing all this because that's what I need to find are the vertices. So my vertices, if I start up here and go counterclockwise, that first one's going to be 0, 240. And then this one, I don't know what it is yet. I got to find that intersection. I don't know what this one is yet. And this one hits at 300, 0. Okay, so now let's do a little bit of work with a piece of paper here. So if I want to find this point here, that's on this line and this line, and if I widen that out a little bit, this line is L2 and this line is L1 and that one's L3. So if I wanted to find this point here, that's on L2 and L1. So I'm going to write that down, L1 and L2. L1, 40x plus 10y equals 2400, and L2 is 10x plus 15y equals 2100. You can get them to match however you want to do it. I'm going to multiply by 3 on top and 2 on the bottom. That's going to get my y's to match up. 120x plus 30y equals 7,200. On the bottom, that's going to be 20x plus 30y equals 4,200. I'm going to subtract. 120 minus 20 is 100. Those guys drop out. This is going to be 3,000. X equals 30. Then you're going to plug back in to figure out what y is. And I'm going to help you out a little bit. I think y is 3,000. Now let me plug it in. Let me make sure. If I did it here, that's going to be 10. I'll put 30 right here plus 15y equals 2,100. So that's going to be 300. So I got 5y, 15y equals 1,800. Y is equal to 120. So that's the point, 30, comma, 120. Having trouble keeping everything on the screen. So when I go back to my graph, this point here is 30, comma, 120. Okay, last point is this one right here. This is L2 and L3. L2, L3. I'm going to try to get through this a little quicker so I don't bore you to death. Copying 10x plus 15y equals 2,100. L3 is 5x plus 15y, that's good, equals 1,500. All we got to do is subtract because I've already got the 15y's. So that's 5x equals 600, x equals 120. If I plug that back in, I believe y is 60. Do some quick math here. Yep. So that's the point 120, comma, 60. So when I come back over here, 120, comma, 60. Okay, now that's all the hard work. My cost function, if you go back, my cost is simply 6x plus 8y. So I got to find the cost at, the first point up here was 0, comma, 240. So that's going to be 6 times 0 and 8 times this. That's going to be 1920. Then I'm going to find the cost of 30, comma, 120. Okay, so that 6 times 30 is 180, and 8 times this is going to be 960. So 960 and 180 is, I believe, 1140. Then to find the cost at 120, comma, 60. So that's kind of, I'm going to cheat on this one. So I'm going to go 6, 120 plus 8 and 60, 1,200. And the last one is the cost at 300, comma 0. So that's going to be 1,800. Let me check something real quick before I get too far ahead. Yep, I think my numbers are right. So, finish it up here. We're finding a minimum. We want to minimize cost. So my minimum cost equals, what's my smallest one here? 1140. And remember, that was in cents, so that's $11.40. At the point 30, comma 120. So that means 30 brand A pills and 120 brand B pills. Okay, so at this point, I started out with a maximization problem. I just did a minimization problem. And we kind of go back and forth. You need to know how to do each one of them. The big difference is when you graph, it's an unbounded region. Make sure you can find your vertices, but you still plug them into your cost function in this case. And in this one, you try to find a minimum. And that's what we did to do the problem. Okay, there will not be a part 3 on this. The next thing you'll see is lecture for 3.4, which there's nothing new in 3.4, it just expands on what we've already done. All right, that's it.